Hey you guys, welcome to this video. My name is Mary. I am the girl who loves maths, and in this lesson I'm going to teach you all about factoring out monomials. Today we're going to learn how to factor out a monomial. All a monomial is a singular term, which can be a number, a variable, or it can be a product of any real number or variable or variables. Here we have a series of binomials which are made up of two monomials. To factor these binomials, we need to find the greatest common factor. Let's jump straight into a few examples so I can make this easy for you. So in this first problem here, we need to find the greatest common factor. So the biggest number and or letters that go into each of the terms. I can see that each term has a 4 in it. So 4 is going to be our greatest common factor here. There are no letters in common, so it's just going to be 4, and then we'll open up a set of parentheses. Now we need to ask ourselves, 4 times what is going to give me this first term? 4 times x gives me that first term, so I just pop an x in there. Then we need to ask ourselves, 4 times what is going to give us our second term here, positive 4y. So we'll have our positive. 4 times y will give us that 4y. And that's it. That's as simple as it is. There's our answer. 4 and then in brackets x plus y. Let's take a look at problem number 2 over here. We need to find the greatest common factor of these two terms, or these two monomials. The biggest number that goes into 14 and 21 is 7. You might also notice that each term has a g in it, so we're going to take that out as well as the greatest common factor. There are no other letters in common, so let's open up our set of parentheses. Now we need to ask ourselves, 7g times what will give us this first term? Well, 7 times 2 will give me the 14. We already have our g, as you can see it's out the front, so we don't need to pop a g inside the parentheses there. Since we're done with our first term, now we can ask ourselves, 7g times what will give us this second term of positive 21gh? Let's focus on the number first. 7 times positive 3 would give us positive 21. We already have our g out the front, so we don't need to pop another g inside the brackets. However, you will notice that we also have a h in the second term, so let's pop that inside here. And there you have it, problem number 2 complete. On to problem number 3, we need to find the greatest common factor of 6t squared q cubed and negative 12t cubed q to the power of 5. Well, the biggest number that goes into 6 and 12, or negative 12, is positive 6. You'll see that we also have t's that are in common. The first term has a t squared and the second term has a t cubed. Since they both have t's, we're going to pop a t out the front. And then what we do is we take the one with the smallest power. So let's put that t to the power of 2. We also have q's in common. We've got q to the power of 3 and a q to the power of 5. We'll pop a q out the front. Again, we make that to the one with the power of the smallest number. 3 is smaller than 5, so we'll make that q to the power of 3. We'll open up a set of parentheses here. And now we need to ask ourselves, this term, 6t squared q cubed, multiplied by what will give me this first term? You'll notice that the first term already exists out the front here. It's exactly the same. So if we multiply anything by 1, we'll always get the same answer. So we'll just pop a 1 there. Now we need to ask ourselves, 6t squared multiplied by q to the power of 3 times what will give us this second term? Well, 6 times negative 2 will give us the negative 12 here. We've still got some t's and q's to fill out. We still have a t squared out the front. We need one more t to make that the t cubed from over here. So we'll put that t to the power of 1, because if we multiplied t squared by t to the power of 1, we would get t cubed, which is in the second term. The number of q's we need is 2. We've got 3 on the outside of the parentheses, but we need an additional 2 because 3 plus 2 gives us the 5 here. Let me get rid of those arrows so that it looks a little bit neater. You'll notice that in our answer we still have t to the power of 1 written there. We don't have to write the 1 though, so we can actually just get rid of that as the 1 or to the power of 1 is just implied. On to our final problem. Let's factorize this and pull the monomial out the front of the parentheses. Starting with the numbers, the largest number that goes into 18 and 12, or that's really negative 12, but we'll just say 12 for the moment, is 6. 6 is the largest number that goes into each of those. Each term has an A, so we'll pop an A out the front. Again, we always take the one with the lowest power. This has a power of 2, so we'll pop a 2 out the front. Each term also has some B's, so let's pop a B out the front. The smallest power is the power of 1. We can't see it there, but really that's B to the power of 1. So we've got a B to the power of 1 out the front. The first term also includes C to the power of 4. However, that doesn't occur in the second term, so we can't take that out the front as a common factor. That means it's time for us to open up our set of parentheses. Let me just get rid of these boxes. Now we can ask ourselves, 6a squared b to the power of 1 multiplied by what will give us this first term here? Well, 6 times 3 will give us the 18. We already have an a squared out the front, so I don't need to pop any a's out the front of the parentheses right now. On to the b's. Well, we need b to the power of 3. We only have b to the power of 1 outside the parentheses at the moment, so we need another 2. So let's make that b squared. Because if we multiplied those out, b to the power of 1 times b to the power of 2. When we're multiplying, we just add the indices. So that gives us the b to the power of 3, which is what we want in the first term. We can't forget this c to the power of 4, so we'll tack him on the end here. On to the second term, 6a squared times b to the power of 1 will give us the second term. Well, 6 times negative 2 gives us the negative 12. We have an a squared out the front, but we need a to the power of 5. So that tells us we need 3 more a's, so we'll do a to the power of 3. We have a b to the power of 1 out the front, and that's all we need. We don't need any more b's. So what that tells us now is that we've completed the problem and that the factored version of this binomial looks like this. I hope this lesson was just what you were looking for. Make sure you hit the subscribe button and ring that bell to be notified when I post new videos. I'll see you in my next lesson. Bye.